So in this very first lesson, we are going to introduce a lot of concepts. Basically, we are going to discuss about two pillars of the software security or cybersecurity, which everything else is built on top. So that is the main topic. So we'll start with a little bit of basics of computer science, all the basic building blocks we will discuss, and then we get into the pillars of security. The first pillar being cryptography, and the second being the rings of protection or local security. We'll introduce both and we'll look into some of the details. So before we start any kind of discussion, we need to understand what we are securing. What is security or information security is all about. So we have the hardware, which consists of the CPU, the main chip, which processes everything. That is what the basics of computing or the fundamental of compute, the CPU. Then we have the memory, memory of any computer system, and always there is associated disk. Now we have other things like the NIC card, which is kind of relevant to the discussion, which is a device which communicates with the network. And there are other devices like keyboard, mouse, graphics card, all different devices. Probably we'll stick to a discussion to NIC card, disk, CPU, and memory. Now what we are securing in this, what is the security is all about? Are we going to secure that someone doesn't snatch our CPU? In fact, that's called a physical security, but that's not what we are going to discuss here. We are going to discuss information security, which is the information, the data inside different storages. Even CPU can have data. We'll see some of the cases in which the security of data within the CPU, some of the caches of the CPU comes into real problem in the future sessions. But what we are securing is the data within the computer systems. Data going through the network. For example, there are data flows from the CPU to the NIC card or memory to the NIC card and goes to the network. So this is the network, and it goes to another system. So this is another system which has its own CPU, memory, and NIC. So this system right here is connected to the network, and it has its own NIC, CPU, memory, and disk. So protection of this data we are giving to the network, and protection of data within this computer system right here. When we say protecting, we mean that we are protecting it from access of others, tampering of the data from a unintented entity, malicious uses of any type for that matter. So we'll talk about different programs, malwares, different prevention techniques, all sorts of different things. So the whole training is all about how to protect the data flows within these systems, within the computer system. The diagram which we have drawn here is true in the case of cloud, on-prem. It is even true for the phones which we are using, or any computer devices, edge devices, anything you can think of. This particular diagram we drawn here is more or less the same. So once again, where all the data goes in the CPU, memory, disk, and of course the network, and potentially other devices like monitor, keyboard, mouse, etc., which doesn't really matter to our discussion, but in some cases it matters as well. But in general, different types of devices which include a disk and NIC card, especially for network communication, and of course CPU and memory. Those are the places we keep our data in a computer system, and that's what we are trying to secure. So any information security paradigm, any security discussion, or any security products or design patterns, anything and everything related to cybersecurity is built on top of mainly two pillars. One pillar is something you might be heard of, at least you might have heard of before, which is called cryptography. It's a branch of mathematics. So cryptography is one of the main pillars of software security or information security in general. There is different algorithms and forms and shapes this particular subject takes. In terms of security, we will discuss almost all of them in this particular training. Although this training is not a cryptography specific training, we will not get into the mathematics. Not a lot of mathematics. We will just get into one algorithm, which you see by far one of the most complicated one, to get a feel of how things works. But otherwise, all we need to understand right here is that cryptography is one of the two pillars of security. Certain algorithms like RSA algorithms, symmetric encryption algorithms, if they are compromised, we will not see the world as we see today. For example, TLS is compromised somehow. Hashing is compromised somehow. SHA-256 or any of the major hashing algorithms, which are nothing but crypto algorithms, cryptography algorithms. If they are compromised today, we will not see the world as we see it today. Banking systems, healthcare, defense, everything we know depends on one of these two pillars. In fact, both the pillars. The second pillar I'm yet to discuss. So it is a very fundamental pillar of the software security. Now the next pillar is a couple of bits inside the CPU. I'm going to call it rings. We'll see the significance of this particular name right here. Rings of security. At the end of the day, these are nothing but a couple of bits inside CPU. Unlike cryptography, which is fairly straightforward to understand, RSA algorithm is not that straightforward, or getting into a specific cryptographic algorithm is not straightforward, especially the modern ones like AES and things like that. But the overall idea, to get the overall idea of cryptography is fairly straightforward. These bits are fairly complicated. We will get into the nuts and bolts of it. We'll need a little bit of patience to get into it. So these bits are probably slightly more important than cryptography. Probably if a cryptographic algorithm like, say for example, RSA is compromised today, you will leave a couple more days. That if one of this thing is compromised, probably it's going to be an immediate end with no exaggeration. So what this particular bits are doing. So these are bits inside the CPU. We'll see in detail how they work and things like that. But ultimately what they does is they implement something called processes inside the operating system. Processes or processes, depends on your taste of pronunciation, doesn't matter. Basically, Linux as well as Windows use this term on a synonymous way. There are other operating system terms like task, thread, and things like that. I'm not getting into any other complication. I'll explain what this means. The idea is isolating one program from other, or other ways, implementing different privileges within an operating system. So implementation of privilege. So that is what these bits inside the CPU does. I know it is a very abstract kind of discussion I'm doing, but we'll get into the details. So be patient about it. But at the end of the day, you can think of these are implementation of processes in different operating systems like Linux and Windows. For example, if you see Task Manager, you can see that the kernel itself, the operating system kernel itself, is an artifact of these rings. You might have heard about, if you have looked into some of the attacks on certain systems, you might have heard about something called privilege escalation. That is nothing but bypassing this particular thingy right here, one way or the other. So you have a lesser privilege and you are tricking the operating system or the application, some application or the operating system to elevate your privilege. Get into the kernel, and take control of the operating system or act as an admin or super user. So it is called privilege escalation. We'll discuss how it is implemented and all the related details, intricacies, and rigor of how this is implemented. So this is also called local security. Local. So why it is called local is mostly these bits and processes kind of isolate application running within the exact same system, local to the physical hardware. So in modern terms, these processes means that it could be a virtual machine running in a cloud, for example, EC2 instance in AWS or an Azure VM or anything like that. Azure VM is nothing but a process inside the hypervisor, very similar to what we are discussing here. It could be a Docker container, containers, any kind of sandboxing technology. It's all about sandboxing technology, isolating one thing from another. AWS must be running hundreds of VM together in a hardware, your VM as well as your competitor's VM, but you don't know each other. It is achieved through this rings of protection, which we will discuss. Same technology, same kind of bits is used for creating VMs, processes, other kind of sandboxes, even application virtualization and things like that. So this is called local security. The concept of user. The concept of user is created using these bits we are going to discuss. So local security, the concept of user, the admin user, normal user, different users of an operating system, different processes. It boils down to processes. Also the file system security. A file can be accessed by a certain user, file system. Role-based access control. Most of the role-based access control is built on top of processes or admin controls. Role-based access control, airbag. Basically, all of these security measures can be bypassed if these bits are bypassed. That's a point here. So this is called local security because it is local to the hardware. Now what is non-local security? So that's what the cryptography mostly is about, not entirely about. There are some overlap between these two pillars. Coming back to the cryptography pillar. So there are different cryptographic algorithms available. Most of them are used for, not all of them, are used for connected security, connected in transit. So connected security or in transit security, most of the time, not always. So what is connected security? So local security is all about the local hardware setting. How about when you send a packet to the network? For example, you're accessing Google, you're accessing your Gmail, your bank account. You're sending packets to the network. How do you make sure that it is secure? How do you make sure that your bank account is not modified by someone else? That's where these pillars come into the picture, the pillar number 1. Of course, along with pillar number 2. But the connected security, when the packets are in the network, it is visible to the whole world, essentially speaking. For example, when you receive a phone call in your cell phone, not sure you have thought about it, that exact same signal is coming to your friend who is sitting in the same room, or anyone who is within the vicinity of the tower is getting the exact same signal. But the phone call you're getting is only coming to your phone. Although others are getting the same signal, they are not able to get that call because that communication is encrypted. So we use this thing every day, every single minute in our life. So there are a couple of algorithms which worth mentioning here. It's not a full list, but we will get into details later. One is PKI or RSA/RSA or asymmetric encryption. Then symmetric encryption. For example, in the case of your cell phone example, which I mentioned, mostly it is symmetric encryption and the key is within your SIM card. Not getting into the details. In fact, we will not get into that detail in the training. Just it came up in my mind while I was discussing, so put it out there. We will not discuss telephone security or cell phone security in this training. We have a lot more other interesting thing to talk about, but if you have questions, feel free to ask. But symmetric encryption and asymmetric encryption, the PKE, RSA. And another thing worth mentioning is hashing, another very important security cryptography mechanisms. When you combine hashing and RSA, you can use it for digital signatures or signing digital signatures. And we will see these algorithms one by one, mostly in detail, at least in some detail. We'll not get into the full mathematics of the cryptography, but we will get the idea, especially PKI. Probably the only difficult thing to understand here is the PKI, which we are going to do next, the PKI. Now let's quickly discuss what are the things depends on this particular algorithms, cryptographic algorithms. So for example, the digital signature. We'll discuss about digital signature. It's a very important topic from our perspective. It uses both PKA and hashing, and in certain cases, the symmetric encryption is also used in terms of transferring the content and things like that. But otherwise, it's mostly PKA and hashing. Now, PKA and symmetric encryption both are used. The PKA and symmetric is used for so-called TLS or SSL. TLS is the new name, or transport layer security. Probably one of the single most important protocol or algorithm as long as the internet is concerned. If this is having some issue, we are all in trouble. You, me, every single person. We'll discuss in fair amount of detail in TLS. So what is TLS is built of? TLS is built of PKI/RSA, which we will discuss, and symmetric encryption. Both are two different encryption paradigms we'll discuss, but TLS is made of these two items. In fact, TLS uses hashing as well. We'll see that in the case of certificate and signing and things like that, but mostly we'll attribute to RSA and symmetric encryption. Now, the PKI/RSA and hashing. This is used for so many different technologies. For example, SAML authentication. Any of these things, don't worry about it. We'll discuss all these stuff in detail. In fact, any of the things we have discussed, VM, container, privilege process, anything we have discussed so far, if you have not heard about it, nothing to worry, we'll discuss. If you have heard about it, well and good. Anyway, we will discuss. TLS, SSL, everything and anything could be new to you, but this is just an introductory thing. What we are doing is just what is this course about, what we are going to discuss, how these things are related. Those are the things we are trying to cover here. So nothing to worry about it. I'm not expecting you to know some of the things I'm going to say just now. For example, SAML is depending on PKA and hashing, and of course TLS, SSL as well. So for example, I will draw this arrow right here towards SAML. Let me take a different color. As usual, my diagram is getting very ugly, but we will leave with it for the time being. So this arrow is not correct. I'm going to remove it. That is from the symmetric. Although symmetric will be used inside SSL, I'm not going to put that there. So hashing and PKI directly used in SAML. And of course, TLS SSL is using symmetric and PKI. You see the relation between all these things. SAML is one of the important authentication authorization protocol or paradigm. Another is, I'm sure every one of you has used auth. Auth is a protocol in which you use to authenticate. Auth plus OIDC provider. We'll discuss these things. These are things or the protocol we use to log into Google, Facebook, Instagram, pretty much everything out there you can think of. You may have seen certain application asking you log into Facebook to log into that application. So that is achieved using auth and OIDC provider. Auth 2, if you will. SAML, you might have been familiar if you're working in a corporate environment. SAML is used for single sign-on. In fact, both of these are very parallel stuffs, mostly used for single sign-on and things like that. SAML especially used for single sign-on. The dependency chart of SAML and all these OAuth2 and OIDC are exactly same. They depend on PKI, hashing, and TLS. TLS in turn depends on PKI and symmetric encryption. So there are a few more things worth discussing which only depends on symmetric. For example, Kerberos. We'll not get into much details of Kerberos or NTLM. We'll see how it is getting used and basic protocol information. Another is NTLM. There are different protocols which just uses symmetric cryptography. Worth mentioning here, NTLM and Kerberos. We'll have chapters on NTLM and Kerberos coming up. We'll discuss it, but probably not in huge detail. Another thing worth discussing is, I have said there are two pillars, cryptography and the rings. The privilege rings, if I call. So there are certain technologies or paradigms out there which uses both of these. For example, secure boot. So I'm going to draw a block here which uses both the pillars. In fact, everything uses both the pillars at the end of the day. This one particular bit worth mentioning. So I'm trying to color it in a different color so that you will understand it is using both the pillars. Secure boot, or SB, I'm going to put. If I start writing more into this diagram, which is already very ugly so far, it'll get more complicated. But it is secure boot. We'll see some details about secure boot, but it uses both the digital signature check and these bits to ensure that the operating system itself is not corrupted. The operating system itself is something we can trust. We'll get into those details. Just to mention that there are technologies out there which uses both the pillars. So long story short, there are two pillars of security, software or cybersecurity. One is cryptography, another is the rings, the privilege rings. The privilege rings implement processes, VM, containers, pods, all kind of sandboxes in general. Isolate one program from another, protect one program from another. It is also called local security. It implement different privilege within an operating system, within a hypervisor. So that is the use of rings. Cryptography mainly used. So that is very important because cryptography is also used in local security. For example, disk encryption and things like that, we'll see that. But mainly used for TLS, connected security, SAML, OAuth, and authentication and authorization and things like that. Whenever you send packet to the network, that is when this particular pillar comes into the picture. There are other uses of this particular pillar. For example, cryptocurrency, which is not really something related to security itself, but it uses pretty much PKI, symmetric encryption, and of course hashing cryptocurrency. Especially it's a magic by using the PKI in a specific way. Now, all the cyber attacks, all the malwares out there, ransomware, virus, worms, pretty much any misbehaving software out there or attackers out there, they are bypassing either one of these things we have discussed or a combination of things. They are doing something they are not supposed to do within the framework of the security. Mostly due to a bug or a vulnerability, we call it, in the implementation of one of the things you are seeing at the screen right now, or a combination of those things. We'll discuss that as well along the way, vulnerabilities and how all the attacks happens normally. And I'll tell you what are the challenges associated with some of these things as well. We'll go through some of the live attack incidents, actual real incidents, hopefully, and we'll see what went wrong and how some of these things we are discussing right here got misused in those attacks. So in the first part of the training, we will try to get our head around these part, the cryptography part of the security pillar, and then we will get into this and explore some of the things. And then we try to get into all the different items, different protocols, TLS, SSH. For example, SSH uses PKI. It doesn't use PKI, it just uses RSA. And other systems like role-based access control, AWS IAM, for example, Kubernetes roles and role binding, for example. All the major softwares which uses these technologies and present it to you in a very user-friendly manner. We'll discuss them. So that was a rather elaborate introduction, rather long introduction about what we are going to discuss. So we have seen the two pillars on which everything else is built on top of, and we discussed a little bit about the cryptography pillar. Now, what we are going to do is we are going to dissect each and every pillar, and we're going to understand what is comprising each of these pillars. Thank you very much, and see you in the next lesson.